Hi everyone, my name is John Cameron and this is my COSC 560 project demonstration presentation. So my app is a platform for playing single player or multiplayer checkers. Once it's completed, users will be able to register, later log in, with a database storing their name, email, an avatar image and a password. The app uses Vue on the front end and Express, Node and Mongo Cloud on the back end. The Vue app is organized in single file components with a main.js file, an app.vue file, and subcomponents are routed through a router. So I've got my main.js, my app file, app.vue, I've got the header, and I've got everything else going through the router, which is routed through a routes.js file. Each component file has an HTML template, a JavaScript section, and a CSS style section. I really like the way that Vue kind of sets things out like that. Okay, so let's have a look at the game. I'll quickly just log in and we'll have a look at what I've got so far. So I've got the registration working. I've got the server basically up and running. Once the game is complete, I will have three main gameplay options, and that's versus computer, which is not implemented yet, finding a player online, or playing two players on this computer. So the main thing we'll be having a look at in this presentation is playing someone else online. Let me just click on that there. Now I've got one other person online. Just quickly log her back in. Yep, there we go. Okay, so Selena is logged in on one browser, John is logged in on the other. They can see each other because their details are being emitted through WebSockets. Now that is happening after they sign up. We've validated the user, after they've signed in. That is posted to the server. The server is then opening up a login socket. So we've got I'm using socket.io here. I've got a number of sockets. We've got a login socket channel here, and it is broadcasting everyone who's logged in. If the user email is unique, because we don't want to have duplicates showing up in this list here. So they're both online. The next thing that they can do is challenge. So this is John logged in here. He would like to challenge Selena. He clicks on the play button there. This creates a new game, and we can see this game in the Mongo database. Let me just update this one here. We should be able to see two documents. There we go, it's updated now. So this URL here is based on a unique ID created by Mongo database when the game is pushed. So that's this game here. Now the game that is stored on the server now, it's initially created in the, choose game. It's receiving via props from the main app, the user, the players, and the game model. All of these models are just data model files that I've created. So I've got, for example, a user model, the game board model with all of the tiles. I'll talk more about these later, and basically what each player more or less looks like. These are all combined into a game. So let's have a look at our game here. It creates a game with an array of moves. This will update over time as the pieces are moved. Player 1 is John. John has blue pieces. Player 2 is Selena. Selena has red pieces. Quickly have a look at the tiles. We've got 32 tiles, and they are in positions 1 from the top left to 32 in the bottom right. So red are in positions 1 to 12, blue is in positions 21 to 32. We can see that here in the database. Blue is the first blue 1 is at position 21, blue 12 is at 32. Likewise for player 2 who is playing red, red 1 should be in position 1, red 12 in position 12. Each piece and each tile has a position, an X coordinate and a Y coordinate to map out on the SVG file here. Okay, so we've got 2 players logged in. We've got a game challenge. So John has challenged Selena. When that happened, Selena received a message that John has challenged her. So Selena will accept, and now we are on the same game URL here as the game we just created. Now I'll just pop this into side-by-side view. So we see we're on the same URL here. Now this has routed us to the game container component, and inside the game container I've got 3 subcomponents. I've got a game scoreboard, a game board, which is our main SVG, and a game chat function as well. The game container contains all of the game's state. It has, in addition to the game board, the scoreboard, and the chat, it's importing directly the player models and the game board tile models. These are updated over time. So the first thing it does after the game has been created, game container, once it's mounted, will post the ID of the game it's trying to find. Now it selects this simply by splitting the URL. So it's just getting the component of the URL after the word game slash, which happens to be the ID that we're looking for. It posts that to the board, it posts that to the server, and then it gets the completed game in response. So it's picking up all of this game detail in response. So both players, this happens on game container for both players when they are routed through to the game container. Okay, so after we've got that, now we've had a look at the players. All right. Sorry, just finding my place here. Okay, so let's have a look at the gameplay. So in this case, Selena is red, and it's set up so that red goes first. So this is John on the left and Selena on the right. Selena moves first. Now we'll just quickly have a look at the logic that's implemented here. I'll go back to the database as we can see it in this in Mongo. Now Selena has red pieces. If we have a look at the pieces, they are positions 1 through to position 12, red 1 through to 12. Red 1, for example, that's this one here, has a position, an X, and a Y. So that's the piece, and it's on the corresponding tile. The tile, the dark gray square behind it, also has the position, the X, and the Y coordinate, but it also has a few more details. It has occupied red, stating that there is a red piece on the tile. It has a number of valid moves and a number of valid jumps. What this means is, if a piece is on position 1, given other logic as well, that piece can move to position 5 and position 6, but there's no positions behind 1 that it can move to. Also, there are jumps. The piece can jump to position 10, which is here, but it can't jump anywhere else because those positions are off the board. So valid moves and valid jumps are not the only logic that the game is looking for in order to make a jump. it also has to meet some other criteria. So in game board, if I can just find that, I'll close that down. There we go. Game board has two main methods that are essentially responsible for a lot of the logic. The first method is select piece. The second method is drop piece. So these are the main things that we're doing. So select piece, it's finding the piece, and if a valid move also meets other criteria, it's then pushed to an array called allowed moves. So that is here in valid moves. If the position is greater than the selected tile, now this is important because initially red pieces can only move to tiles with a greater position number. So 1 can only move towards 5 or 6. 5 can only move towards 9 or 10. It can't move back to 1 or 2 unless it's crowned. And I'll talk about crowning later. So red can only move this way, blue can only move this way. So that's one piece of logic. The other piece is if that tile is not occupied by red or blue or not false, not off the board, if these things are possible, the move is allowed. So from position 1, there's no moves allowed, but positions 9, 10, 11, and 12, there are allowed moves. I'll move position 10. 10 can move to either 14 or 15. Let's move to 15. So position 10 has moved to 15. Now what that's done is gone to the other main method here, which is drop piece. Drop piece, once it gets the selected piece, we'll find if the tile is empty, if it met all of those criteria, we're going to drop it in that position. And then we need to update the position, the X, and the Y coordinate. So I'll just refresh that. We should see red 10 has now updated. Oh, it's this one here. That's the one. If we look at red 10 now, red 10 is now in position 15. That's one of the things I needed to do. The other thing is go back to the tile and change it from occupied red to occupied empty. So it should have done that as well. Back in the database, if I go back to tile 10, which was occupied red, it is now occupied empty. So it set that logic, and then the method to send that to the server is post move. We'll have a look at post move, which is a little further down. Post move does two things. It posts it to the server, but it also emits it to a socket called game data. Now it's game data in a room based on that ID, so there's no cross data coming from other games that are concurrently happening. So this will only go to game data socket to the room with this unique ID. Okay, so that's posted. The game socket is the game data is emitted to the socket. If we have a look at game container is listening for any update. So we're listening for board updates. This socket is opened at the beginning when game container is first initialized. So the socket is open, it's listening. If it sees that there's an update, it updates the current state. And as I said, all of that state is sent through as props back to the game board and the scoreboard and the chat. So if we go back, John's made the move, but Selena's board is also showing that that move has happened. So let's have a quick look. I'm sorry, Selena made the move, but John's board is also showing that that move has happened. So now we're over here on John's board. John can move blue. In addition to moves, there's also the jumps. We had a look at the corresponding jumps for each valid move. I'll just quickly show that again. So in this case, red 10 is now in position 15, and we've got this jump available. This is done. I'll just refresh that again. Player 2, Selena. Red 10. It's in position 15. If we look at tile 15, we've got a set of valid moves and valid jumps. So the way that I've made this logic kind of work out is each valid jump corresponds to the same array position as the valid move. So in this case, position 15 has a valid move to position 18 and a valid jump to position 22. So 18 and 22 are corresponding here, and that would be going this way. In this case, we are looking at position 19 that this blue piece is in, and the valid jump is to position 24 there. Now, Selena has just made that move and captured John's piece. Very briefly, I'll just have a quick look at that logic there. So in select piece, in addition to pushing to an array of allowed moves, we're also pushing to an array of allowed jumps. And that is here. So we're pushing to an array of allowed jumps given that there is an opponent's piece in the allowed moves, in an allowed move, and the corresponding allowed jump is empty. In those conditions, the jump is allowed and the piece is dropped. Drop piece looks for jumps first. If there are no jumps on this piece and no jumps on any other piece, only under those conditions is a move allowed. Now what I mean by that is, Selena has made this jump, and now John's turn. There should be allowed moves here, but there are no allowed moves because if there is an allowed jump, only the jumps can happen. We can't make a move if there is an allowed jump. So in this case, I will jump to here. So that's basically the logic at its simplest point, but there's a number of more difficult pieces of logic that I've had to implement. So for example, if a jump is available, I've just mentioned that if a jump's available, the player must make that jump. In addition to that, if the player jumps and then there's another jump available, the player needs to jump again. So I'll just try and demonstrate what that would look like. So I might just move a few of these around. Just move this one here. I'll move you and this one. I'll move this one forward. Move one more blue. Okay, now blue is set up for a jump. Blue jumps to here, but then because there's another jump available, the turn has not changed and John needs to make another jump here. He jumps again, he gets to the end of the board, now he has a crown. So this is some of the more complicated logic that I've needed to implement. First of all, in terms of the crown, after every move, I've got a method checking if this piece can be crowned. So I've got a method called crown piece. Looking at crown piece, if a blue can make it to positions 1, 2, 3, or 4, or if a red can make it to positions 29, 30, 31, or 32, that piece is then crowned. So what I mean by that, if I just refresh our game here, Now blue, John's piece, just got a crown. That looks like it is maybe blue 4 or blue 5. Blue 8. So blue 8, and I'm having a little bit of trouble with this logic. Blue 8 has moved to position 1. In this position, this should say crowned true, and this is something that I'm trying to work on. But when there's multi-jumps happening, something about the multi-jump is it is actually crowning. It's turning that crown to true, but then when it's posting to the server, it's posting as false. So that's something that I actually do need to try and fix up. The other thing about crown piece that I'm finding a little bit difficult to implement is the logic that if you jump and there's another jump available, you need to take that jump unless the piece is crowned. When a piece is crowned, the turn has to change immediately. So that is getting ironed out, but there's still a little bit to do there. Okay, I'm talking a lot, so I'll quickly move on to chat. In addition to opening a game data room with this as with the URL stub as the room name, there's also a chat room opened with the same name. So with chat, I've got game chat is the main component here that we can see. And inside we've got 4 variants on game messages. There's red player opponent message, red player user message, blue player opponent message, and blue player user message. The blue player opponent and blue player user are slightly different. As we can see, if you are the user is John here. The avatar is on the right-hand side. If it's the opponent, the avatar is on the left-hand side. However, I thought it would be a good idea to keep the colors the same as the piece numbers. Selena is red, so on both screens, her message bubble comes up as red. So the game chat is more or less working pretty well. I'm fairly happy with it. There is one thing that if anyone has any hints on, I'm having some problems with. So once the chat gets to the bottom, it is scrolling somewhat. And I can look at that in game chat here. I've got a method called scroll to end. So the idea is that the element will scroll to the end once a new message comes through. However, it's getting to the one message before the end. So as you can see here, I'm writing in number 4. The previous message, which was number 3, is the one that we can see. 4 is hidden somewhere at the bottom here. If I put in another message, now we can see that one. So that's a little bit of trouble that I'm having there with the chat. Okay, so basically that's the app. A lot of it is working. There's still a few things I'm working on. So if I just go back to, I'll open that up. And that's a good example. So sometimes the routing doesn't quite work properly, even though it should. I was still logged in. That should have routed me back to choose game. It routed me to sign up. So what I need to work on, the routing, I need to initiate the, I need to start working on the computer AI so I can have a versus computer option. I'd also like that if a game is completed, or a game is, sorry, not completed yet, we can continue the game. With a click, I would like to see a list of all of the games that the user has open and still playing. They'd be able to choose the game and continue. In the profile section, I've got a few things implemented already. For example, we are able to change the avatar. I've got a carousel of avatars loaded up. Now, John looks pretty fancy there. Okay, and also we can change the name and the email. I want to be able to change the password, but the back-end logic is not sorted out for that just yet. So that's immediately changed. I'm now johnny@email.com. Down here, I would like to be able to record the wins and the losses with the number over here, a list of opponents that we've played, and the win-loss ratio as well. These are things I'd like to implement on this screen. In addition to that, there's a few other things that aren't quite right. I'm very purposely using Chrome in both of these browsers here. The UI looks pretty good in that, but the CSS is doing funny things in Edge and Firefox. I haven't tried Safari, but I think that's pretty similar to Chrome. I mentioned the game chat doesn't scroll all the way to the bottom. In addition, I'll also need to make my analytics screen using D3. One thing I'd love to be able to figure out is on a regular browser like this, not incognito, if we accidentally refresh, we're immediately logged out. I need to sign back in. Even though I can still see this route, I'm not able to press any of the buttons because only the user who's logged in is able to press the buttons, able to press on the pieces. So that's another thing I'd like to figure out. I think there was one more thing. Yeah, so basically I'd like to have local storage somehow keep the user data, and if the token is expired, it won't work, but if the token is still not expired yet, then the user would just be reloaded there. I think that's pretty much where I'm at the moment. I think it's achievable for me to get all of those things done. We've got about 4 weeks before the final due date. So yeah, so far it's going fairly well. If anyone has any comments, any suggestions on how to fix perhaps the scrolling there, or if they know anything about saving user data to local storage, that would be fantastic. Thank you very much.